we are using the intermediate value theorem. So let f be continuous on a function. It's a closed interval from -3 to 2. And then they gave us some values of x are given in this table. And here we are. Here's our inputs. Here's our outputs. Which intervals must contain a solution to the function equaling 2? Well, where's 2 at in this function? So we're looking at 2 as an output. So where's this 2 between when we look at these outputs, right? So is there a 2 between 6 and 1? Yep, there's a 2 there. Is there a 2 between 1 and 5? Yep, there's a 2 there also. Is there a 2 between 5 and 3? No, there's no 2 between 5 and 3. So if we're looking at it, it would be between, and we're looking at the inputs, so between -3 and -1, that's the first one we see, and, or in union with, the other one is between -1 and 0. So between -1 and 0, there has to have intervals that have to have the solution, because it's continuous, so you can't pick up your pencil, and it's in between these two where you have bigger or smaller values, so it has to be between it. Let's see what their answers are. So -3 and -1, -3 and -1 right there, -1 and 0, -1 and 0, and not 0, 2. So that's basically how we're doing these, is we find out where that output's between and then represent it when we look at their inputs, making sure it's a closed interval, just like we've been practicing with continuity. Okay, same game. Let's see. H is continuous function on the closed interval 0 to 4, where h of 0 is equal to 2 and h of 4 is equal to -2. Well, sometimes it might be easier to look at it in form of a table. So I'm going to go ahead and just kind of look at my, does it say these are x's? It doesn't. I'll just call it x. And then this is our h of x. All right. So we're between 0 and 4. 0 and 4, and the output at 0 is 2. The output at 4 is -2. So that means between 0 and 4 is basically there has to be all values. It touches everything between 2 and -2. All right, which of the following is guaranteed by the intermediate value theorem? Which is guaranteed by the intermediate value theorem? All right, so that h is 3, is h 3. 3 is not even possible. 3 is up here, so that's not inside of our outputs. H of c is equal to -1. Is -1 in here? It could be. For at least one c between 0 and 4. Yes, that sounds right. So there has to be at least one. So it looks like the x is not it. They're using the letter c. Okay, cool. Cool for C. Yeah, I missed it right there too. Just like to make things complete if we can, so a little less confusion, right? I like using X as my foundation unless it goes otherwhere. All right, so that one's okay. H is 3. Once again, 3 is not in our intervals as an output. So just be careful. That's the good thing about the table, is it's easier to see what's the input and the output in like a table format for me. All right, and the last one, H of C is -1. -1, that could be for at least one C between -2 and 2. No, -2 is not part of our inputs, so that doesn't fit either. 2 does, but not the -2. All right, so only B. Okay. Let's see anything different on here. So it looks like kind of the same thing as the last one. So between -7 and -1, those are inputs. Which intervals must contain a -2? So just be careful about your negatives. There's a -2 right here. -2 is between 1 and -3. There's a -2 right here, -3 and 5, and from 5 to -7, yes, there's a -2 right there. So it's in between all of these intervals. So just kind of be careful with your negative. If you need to, my advice would be kind of like just call it output so you can see it in this context. The output, we got a, see, I like having my 0 placeholder, and we got a 1, we got a -3, and we got a -7, and we got a 5. All right. And so these are all the outputs. And where's -2 at? -2 is right here. So notice it's kind of in between each one of these, and you can kind of look at it in terms of the outputs. But like I said, it's in all of these, so you just kind of look at it with respect to the inputs. So in between -7 and -5. So yeah, so everything should be straightforward on this one. So yep, -7 and -5, -5 and -3, there's one, -3 and -1, there's one also. All right. And looks like the same kind of game here. Make a table, and then you can make it a little bit easier to analyze. Just be careful about those negatives.